Okay, we're going to find dy dx by implicit differentiation. And so our first step is to apply d dx to both sides of this equation that has both x and y involved. So we don't try, what I'm not going to do is I'm not going to solve for y, which would be, we just wouldn't want to do that. I don't know how to do that anyway. So because it's a cubic in y. So instead we apply d dx on both sides. And so we use what they call linearity of the derivative, which says that I can take the derivative of each of these pieces over the sum here. So each term I take the derivative, and those derivatives are with respect to x. On the right-hand side, the derivative of 5 is just simply 0. Then I go a little further. The derivative of x to the fourth with respect to x is 4x cubed. Now, for x squared, y squared, I need to use the product rule. So I have x squared prime times y squared plus x squared times y squared prime. So I use the product rule there. I'll go on the next step and actually take those derivatives. Now for y to the third power, I'm going to use implicit differentiation. First, the derivative of y to the third is 3y squared with respect to y. But then I take the derivative of y with respect to x. That's how we do implicit differentiation. It's the chain rule. And the derivative with respect to x, I'll write as dy dx or y prime. Now let's work on this product rule piece some more. So for x squared, I write the derivative of x squared is 2x. And then for y squared, I take that derivative, but it's with respect to x. So I'm going to write 2y y prime. That's what we do with implicit differentiation. When I take the derivative with respect to x of y squared, I'll take the derivative of y squared, which is 2y, with respect to y, and then multiply by y prime. And now the next step is to solve for y prime, and I'll use algebra of grouping everything with y prime on the left, and I group everything without y prime on the right. And so my first tool I'm going to do for the grouping and moving things around is by addition and subtraction. So if I were to, I guess I will do this, I'm going to highlight those pieces that have y prime, and I will just show those as staying on one side, on the left-hand side. And it's really a good idea to really pay attention, which unfortunately sometimes I don't do. But pay attention to make sure I'm just copying things down properly. So that's always a good thing, is just to really look over it one more time. All the other things I move to the other side. Okay, so those are the pieces that don't have y prime. And I move those to the right-hand side. Now my next thing is I'm going to factor out y prime on the left, and that leaves 2x squared y plus 3y squared. And on the right, I'll just copy that down a second time. All right, so I'll just copy that down. I'll have 4x cubed minus 2xy squared. And then I'll divide so I get y prime all by itself. Now to me, this looks completely fine, but if I look in the back of the book for this problem, I can try to match it, which is always something sort of satisfying. So first, I can factor out the negative in the numerator, and then also 2x, and that'll leave 2x squared plus y squared. And in the denominator, I can factor out y, and that leaves 2x squared plus 3y. I don't think that that was any better than the line that came right before, but anyway, I'll just write it that way to match that answer in the back of the book. So I was just sort of looking to make sure I got the same thing. All right, before I go, let me zoom out so the whole problem is right in front of us for a last look. And that is solving for y prime or dy dx by using implicit differentiation.